Hello and welcome to this walkthrough video for the GCSE Computer Science 2024 Paper 1 with the OCR exam board. I always point out that there are 90 minutes in a GCSE Computer Science paper, both for Paper 1 and Paper 2, and there are 80 marks available for each paper. So 80 marks in 90 minutes, you've got roughly a minute per mark with approximately 10 minutes left at the end. It's not quite that straightforward on Paper 1 because we do always have an 8-mark essay question in here, and that you should be spending really a little bit more than 8 minutes on. But we'll try and pick up some time as we can. So without further ado, we'll make a start. The first question is a nice easy one to settle with because everybody should be familiar with binary and denary values. This question is asking us to convert between binary and denary, and if we're using 8 bits, if we're using binary, we must write our answer in 8 bits. Having the advantage of having already seen the mark scheme while marking my students' mock exams recently, I'll know that the second answer here must be given in 8-bit binary as indicated in both the question and the table header. So let's make a start on the first one then. So we've got, I've already written this one down. So we've got 4 ones and 4 zeros. So I've split them into nibbles at the moment, but that's not necessary. And all we're doing is we're doubling the value of our binary placeholder value each time we go left. Okay, so you should end up with 4 zeros under the values 1, 2, 4 and 8, so they're irrelevant. And you've got 4 ones under the values of 16, 32, 64 and 128. If you count from right to left, that's fine, but I always go left to right because I find it easier. 128 plus 64 is 192. Let's just make a note of that. 192 plus 32 is 224. And 224 plus 16 is 240. So I'm fairly confident with that being my final answer, 240. There is another method for this though, and you'll see that I wrote it as 2 nibbles. You can approach it in a kind of hexadecimal way if you understand hexadecimal really well. And what I would suggest is you do this. So I'm writing it in blue this time. These digits, if you ignore these values up above and you give them the values 8, 2, 4 and 1 to match this nibble over here, okay, you've got 15 and you've got 0. Now in hexadecimal, normally you would change 15 into F, but we don't need to do that here because there's no hexadecimal as part of this question. All I'm going to do is 15 multiplied by 16 is 240, because 15 times 8 is 120, and if you double it, and then 0 multiplied by 1 is 0, and if you add those two together it's 240. Now it doesn't matter which way you do it because there's no method marks for this question, it's just 3 marks for your 1, 2, 3 separate answers, but whichever way you prefer, go with that one. The second one is asking for 105 in denary to be written in 8-bit binary. Okay, so 105 in denary, just put a line under that. Now, again, if we use those placeholder values here, 128, 64, 32, 16, 8, 4, 2, and 1, does 128 go into our target value of 105? No, it doesn't, so we'll put a 0 there. Does 64 go into 105? Yes, it does, and it also leaves a remaining 41. Does 32 go into 41? Yes, it does, and it leaves 9 remaining. 16 does not go into 9, but 8 does. And that leaves 1 remaining. So we put a 0 in the 4 column, a 0 in the 2 column, and a 1 in the 1 column, which leaves 0 remaining. So our number we're left with, 8 bits, remember, don't miss this 0 because you think it's not significant, is 0110 1001. So I'm going to commit that to my answer here, 0110 1001. Of course, you could do your working here, it's absolutely fine. I've just have the benefit of some spare paper there to the side. And in fact, it might be better to do your working here in the exam or in the back of the paper because whoever's marking your paper can give credit for your method if you've crossed out your answer. And then we've got 3 zeros, 3 zeros, 4 ones and a 0. So I'm just going to use the reverse side of that paper. So I'm going to show you the hexadecimal method now, and again you can use whichever one you prefer. So we've got a 1 in the 1 column because this would be 1, 2, 4, 8 if we use the hex method. We've got a 1 in the 8 column, a 1 in the 4 column, a 1 in the 2 column, and a 0 in the 1 column. So we've got 8 plus 4 is 12, plus 2 is 14. That's going to be multiplied by 1. And we've got a 1 in the 1 column, so that's 1. But that's going to be multiplied by 16, okay? So 14 times 1 added to 1 plus 16 should give us the answer 30. Now let's just check if that is correct, because the other way of doing this, of course, is to ignore this method here and to simply double when you go left. So 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. So we've got 16 plus 8 is 24, plus 4, 28, plus 2 is 30. We've got the same answer both ways, so that must be correct. Nice easy start, nice easy 3 marks, very confident. Let's move on to the second part. Complete the table by writing the answer to each statement. The first statement, the smallest denary number that can be represented by a 4-bit binary number. So if you've got a 4-bit binary number, what's the smallest number you can make? Well, some people make the mistake of thinking that the smallest value is that one, which would be 1. But of course, there's nothing to say that you can't have a 0 in this column and 3 zeros preceding it, which would of course be 0. So the smallest denary number that can be represented by a 4-bit number would be 0. Or you could write your answer as 4 zeros, okay? But it does say the smallest denary number, so. The largest denary number that can be represented by 6-bit binary number. Well, this is easy because all you need is 6 ones and then to work out what they are. So you've got 6 ones, that's worth 1, that's worth 2, that's worth 4, 8, 16 and 32. 32 plus 16 is 48, plus 8 is 56, plus 4 is 60, plus 2 plus 1 is 63. So that's not too difficult either. And in the exam, you're not going to be sort of thinking out loud as I am. So you're probably actually going to fly through these much quicker than I'm doing right now. The maximum number of different colours that can be represented with a colour depth of 7 bits. Okay, I'm going to get a fresh piece of paper for this one. So the maximum number of different colours that can be represented with a colour depth of 7 bits. This is really easy because if you think about it, 7 bits, each bit could be 0 or it could be 1. So I could have 7 bits that look like this, or I could have 7 bits that look like this. The point is, for each bit, we've got 2 options. Okay, so what we're using is a base 2 number system here to the power of 7. So 2 to the power of 7. And that's the same as saying 2 times 2 times 2 times 2 times 2 times 2 times 2, which should be 128. Okay, so 128 should be your answer there. And then the minimum number of bits needed to represent 158 different characters in a character set. Well, we've got the advantage of having just answered that previous question. We know that 7 bits, the maximum number of different colours or numbers that could be represented with 7 bits is 128, going all the way from 0 to 127, inclusive. So the minimum number of bits is going to be more than 7 bits. So it's not too difficult to work out that that's going to be 8 bits, because we know that 8 bits, if all of them are 1, would give us a maximum value of 255. Okay, what I mean by that is this. So if you've got 8 individual bits and they're all 1s, that in denary will be 255. So that's the same as 2 to the power of 8, which is 256 different values, because we've got 0 all the way up to 255. Okay, so nice easy 7 marks to start with there, in my opinion. And then another one that's not too bad as well. Show the result of a left binary shift of 4 places on the binary number 00001111. Okay, so all this means is this. You've got your number, 4 zeros and 4 ones, and the question's asking for a left binary shift. So we've got to go left times 4. Okay, 4 places. So what we're going to do is we're going to cross out those zeros, move these ones to the left, and with a binary shift, we always fill any empty spaces with zeros so that they don't affect or change the value from what it is expected to be. So our answer should be 4 ones and 4 zeros in this order, left to right. 8 marks, easy peasy. And I bet I'm longer than 8 minutes at the moment, but we'll try and speed up. Describe how to convert a 2-digit hexadecimal number into denary. So how do you go about this? Well, my preferred way of doing this, at our school, we've got 2 teachers that teach computing. You've got my method and you've got the other teacher's method. The other teacher's method is safer. Mine is quicker. And I tend to teach them this, students this in year 10 or 11 after they've learnt the original method, the correct binary method. But what I like to do is this. So a 2-digit hexadecimal number into denary, use an example. So starting with, let's say F3, okay, F would be multiplied by 16, okay, and 3 would be multiplied by 1. Now we have to remember that F, the value of F in hex is 15. So it'd be 15 times 16 is 240. And then 3 times 1 is 3. And then we simply add them together, 243. 3 marks. I think that's relatively easy. I'm just trying to think what we could get for the mark scheme. I think it would be 1 mark for multiplying by 16, 1 mark for multiplying by 1, and 1 mark for having a correct final answer. Add these 2 8-bit binary numbers using binary addition and show you're working out. Okay, this is not a bad question either. For 2 marks, relatively straightforward. Okay, there's some rules to this. Okay, 0 plus 0 is 0. 0 plus 1 in any order is 1, so it could be 1 plus 0 equals 1 as well. And then 1 plus 1 equals 1, 0. Okay, so they're the rules we must bear in mind at all times. So 1 plus 1 is 1, 0. We just wrote that down. But we can't put 1, 0 here. So what we do, like we do in standard maths, is we put a 0 in this column and we carry the 1. Okay. Now we've got 1 plus 1 plus 1. Oh, I forgot one of my rules. 1 plus 1 plus 1 is 1, 1. Okay. So 1 plus 1 plus 1 is 1, 1. So we put a 1 in this column and we carry the 1 to the left. 0 plus 1 plus 1, that's 1, 0. So we put a 0 here, carry the 1. And you can see there's a pattern emerging. 1 plus 1 plus 1 is 1, carry the 1. But for the first time here, we've got 2 zeros in the top rows. So 0 plus 0 plus 1, nice and easy, that's 1. 1 plus 0 is 1, 1 plus 0 is 1, and 0 plus 0 is 0. So our final answer, 0, 1, 1, 1, 1, 0, 1, 0. Another nice 2 marks. Thank you very much. Okay, question 2. We get on to IP and MAC addresses now. So an airport has computers that are connected together on a local area network. Each computer has an IP address and a MAC address. Give one example, a valid example of an IPv4 address and one example of an IPv6 address. Okay. I always tell my students just to remember this. 4 8s separated by 3 dots. That's a valid example of an IPv4 address, because the rules behind this are that an IPv4 address needs to have 4 sets of numbers, denary numbers usually, and those numbers have to be between 0 to 255 each, and they're separated by dots or full stops. Okay, or if you're American, periods. So 4 sets of denary numbers, each of them have to be between 0 to 255 each, and they're separated by dots. So 8.8.8.8 would be perfectly valid. The IPv6 is a little bit more tricky though, because this is where we have, and typically students make a mistake here and think that it's 6 groups of numbers because it's called IPv6. That's true if you're using hexadecimal values, okay? But let's say that we're going to use, sorry, that's true of MAC addresses. Sorry, I should have said, it's because MAC address is in the question there. when you're doing IPv6, it has to be 8 groups of hexadecimal numbers, okay? So you can use any hex values. So I could have FF. These are separated with a colon, by the way. I could have 0, 0. So there's my lowest value and my highest number next to each other. I could have something in the middle like 9, 8, separated by a colon. I can have 7, 5. It doesn't really matter whatever you do here, so long as they're valid hexadecimal numbers. CD 0, 2. How many have I got? 1, 2, 3, 4, 5, 6, 7. I need one more. Let's go with my favourite number, 32 at the end. Okay, shouldn't have put a full stop there. Okay, so 4 sets of denary numbers separated by full stops. The denary numbers have to be between 0 to 255. 8 sets of hexadecimal numbers. Lowest can be 0, 0. The highest can be FF. Okay, so I shouldn't be seeing any G's, H's, or anything like that in here. All right, nice and straightforward, that one. Describe the format of a MAC address. Okay, this is where I made the mistake a second ago, wasn't it? Where I said about 6 sets of hexadecimal numbers. So a MAC address is 6 sets of hex values. Okay. Can also be presented in binary or denary as well, but obviously that's going to change how long it is. And these are separated by either a hyphen, like a dash, or a colon. Okay. And it's a 2-mark question, so I think that would hit both of those. The airport currently has wired connections in their LAN. Describe 2 benefits to the airport of using wired connections in their networks. So basically, why is wired better than wireless? Well, wired would give faster speed of upload or download due to higher bandwidth. How many marks is this? 4 marks. So what benefit would that have on the airport? This could potentially speed up data transactions and reduce queuing or waiting time. Okay, so they can process their customers or their baggage or their purchases in the duty-free faster. What else? Wireless, sometimes you go to like a hospital or a doctor's surgery and they ask you to turn off your mobile device because it can interfere with the technology. So I'm going to go with that one. I'm going to say less interference with radio communication technology. I don't know how true or valid that is nowadays. So you might be better to say something like it's more secure because it's harder to hack or something like that. I'm actually struggling to relate this now. Less interference with radio communication technology. I'm just trying to relate that to the airport. The benefit of that would be pilot / staff / customers communication is more secure and stable. There we go. I might be stretching a little bit to get that 4th mark, but I think I would have given that. Again, not having the mark scheme next to me, it's at least 3 out of 4 there. Explain the reasons why the airport should also allow the network to be accessed using a wireless connection. So if you want to use a wireless connection, that's obviously going to benefit people that have mobile phones. So customers can't connect to the network. If it is only wired. So making it wireless would mean that more people could connect. Staff could move more freely without needing to disconnect and reconnect. And it says a third one. Good as a backup, maybe? If the wired connection was damaged, maybe rats had chewed through it. Good as a backup in case of issues with wired LAN. So I think I've made 3 valid points there to get all 3 of those marks. We're still on this question. One office in the airport has 5 computers connected to one switch. So a switch normally sits in the middle of a network. There are 2 printers in the office that can be accessed by all computers. Draw a diagram to show, oh blimey, I didn't plan for this, did I? Okay, so let's just draw a circle in the middle and give this an S. Let's have, how many computers was it? 5 computers and 2 printers. Okay, so let's say computer, 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 and another computer, and then 2 printers. Is that what it's asking for? Using the star topology, draw a diagram. Yeah. Switch and 2 printers. Yeah. That seems relatively easy for 3 marks, but there we go. If you know what a star topology is and you know that you understand that a switch should sit in the middle, that's really, really easy. I should probably put SW so they don't think I mean server. So SW, PR for printer, and C for computer or client. Give one benefit and one drawback of the office using a star topology instead of a mesh. Okay, so a benefit of a star topology over a mesh is that you can if you've got many computers connected, if one client were to fail, the rest of the network is unaffected, which is obviously quite good if you've got, say, 20 people connected and you've got one PC that's not working. Typically this happens in my classroom. I've got 32 student PCs. It's quite often, maybe not every day, but maybe once a week, that one computer will fail or need a reboot or need a restart or a software update or something like that. It's fine because I've got 31 others and rarely have a class of 31 students. And a drawback though, so kind of the extreme version of that, if the switch fails, the network goes down. There we go. So 2 marks. Describe the role of the switch in the star topology. I don't love these questions, to be honest. But the first thing that the switch does, you can probably tell from the diagram up there, it connects all of the devices in the network together. Okay. Another thing it does is it receives data or requests from all of the clients in the network. And then what it'll do is it'll direct or redirect data around the network. So it said, describe the role of the switch, 3 marks. I've given 3 separate points. I'm confident that we would get all of those so far. So far, I think we're looking at 3, 8, 11, 13, 15. What have we got here? 20, 24, 27, 30, possibly 32. Maybe we dropped one on that previous page. So 31 out of 32, I would say we're quite safe at the moment. A computer has an operating system and utility software. The table contains operating functions and a task that each function performs. Complete the table by writing the two missing function names and a task performed by the two. So we've got a gap here for function, and we've got a description for task, which says moves data from secondary storage to RAM. Whenever we're talking about RAM and data, we're talking about memory, aren't we? So this one is memory management. And then the second one, we've got the name for the function peripheral management, but no description of the task. This deals with inputs and outputs from input/output devices. So like every time you click on your mouse or tap on your keyboard or something like that, it will receive and transmit those requests. No function name, but we've got a description. Allows the user to create, name and delete folders. Well, folders are part of our management of our files. So this one's nice and straightforward, file management. Always ask my students to have a different folder for each subject in their my documents at school. So file management, that one's quite easy. And then user interface. What does the user interface do? It allows the user to interact with the computer. So 4 marks. What did I say on the previous page? We've got at least 31. We might have 35 or 36 now. And these are nice. You get a 6-mark question where all you have to do is pick what's missing. These are really, really nice. Was there a 6? Oh, there's one at the start. So complete the description of utility system software using the words provided in the box. Not all of the words are used. Something software changes data using a something. Something software changes data using a something. So it's probably not defragmentation. What else have we got? Could be encryption. Could be compression as well, but I think encryption is going to make more sense here, isn't it? Because encryption software changes data using a something. Using an algorithm. Is there an algorithm up there? No. Using a key. There we go. So encryption software changes data using a key. Right, there we go. Where's encryption? There they are. They're next to each other. I should have spotted that. If the changed data is intercepted, it cannot be, it can be read, but it can't be understood very easily. So it can't be understood. This software does not stop the data from being intercepted. Something software analyzes the data on a disk to find files that have been split and stored in separate locations. So this is talking about defragmentation, isn't it? So defragmentation software. The split files are moved to be something in storage and the free space is moved together. So they're moved so that they're next to each other, aren't they? So consecutive will be the best word for that gap. So they're consecutive. I normally use the word contiguous when I'm teaching, which just means that if there's 5 things to store, they're stored in a block of 5 next to each other, which consecutive also covers quite well. This does not provide more storage space on the disk. Instead, it makes the something of the data faster. We've got access, speed. No, it's not about speed of the data. It's about the access of the data, isn't it? So there we go, the access of the data faster, because the read head does not have to move as far to access the next part of the file. Imagine if you've got 5 blocks in a row, you only have to go from A to B to C to D to E to read them all, rather than go from A to Z and then back to C and then to Y and then to D. So that's nice. I reckon we're on 41 or 42 out of 43 so far. Please do not write on this page. Right, that means we've got the essay question coming. Right, now on these videos, what I tend to do is I'll return to this and do this one separately. So I'm just going to read the question real quick, but I will return to this in a separate video because I find it easier to do these at the end if I were a student. I also mark them at the end as a teacher as well so that I can compare and contrast. I won't read the question actually because I'm trying to save time. So I'm going to skip this and come back to it in a follow-up video. A musician uses a computer to make and record music. Tick one box to identify the correct description of sound sampling. The frequency of the wave is measured a set number of times. No, it's not that one. The amplitude of the wave is measured at set intervals. Okay, could be that one. Yeah, the amplitude of the wave is measured at set intervals. That makes sense. The digital sound wave is measured a set number of times each second. That could make sense, but doesn't sound as good as the previous one. And the analog sound wave's resolution is measured. No, it's the second one, isn't it? So we're going to tick that box there. Okay, that's only a 1 marker. It does say tick one box, so don't tick 2 because you'll get 0 if you tick 2. Explain how changing the bit depth will affect the sound file. So if you've got more bits available, how will that affect the sound file? Well, the first most obvious thing is the file size will change. So if you increase the bit depth, file size increases, and if you reduce, it decreases. Don't know why I've taken up so much space with that because it's a 2-mark question. I probably wouldn't have got both marks for that so far. But what we usually tend to say is that there'd be either an improvement in the quality or the accuracy. So I'm going to say quality. Shall I say / accuracy? Will improve. It's only a 2-mark question. If it was worth more, I'd probably go into a bit more depth than that. Musician has run out of storage space on their secondary storage device and needs to buy a replacement. Identify whether they should buy a magnetic secondary storage device or a solid state secondary device and justify your choice. So both of these would be valid answers, but I'm going to go with, why did I just put secondary? I'm going to go with solid state because the prices now are not drastically different between magnetic and solid state. Solid states are smaller, lighter, so they're more portable. You can put them in a bag, a laptop bag, a pocket, without really noticing them. They weigh less than most mobile phones now. They're faster, they make less noise, they don't get hot. You can plug them in and they're compatible with many different types of devices. So I think there's several reasons why I would go for solid state here. So price is not drastically different to an equivalent magnetic device. But capacity is going to be large enough, or I'm going to say comparable, because price and capacity generally are quite comparable now. Speed of read/write is faster. So here's where we should be talking about capacity, durability, reliability, portability, cost, and those types of things. So capacity is going to be comparable, speed is going to be faster. They are smaller and more lightweight, so easily portable. They are also quiet because they have no moving parts, and more durable. So if you drop them, for example, they're very unlikely to be damaged. I've put a memory stick through the washing machine twice accidentally because it was in a pair of zip-up trousers, in a pocket, sorry, a zip-up pocket of some trousers, and the Once it had dried out, it did work both times. I wouldn't recommend trying it, but it did work. Identify one other type of secondary storage. So you've already had magnetic and solid state in the question, so the only other one is going to be a disk, an optical disk. So a CD or a DVD or something like that. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. We skipped the essay question, didn't we? And before the essay question, I thought we might be on 41 or 42. So we're either on 49 or 50 right now, and we haven't done the essay question. Tick one box to identify the smallest secondary storage capacity. Right. Okay, these questions can easily trip people up. This is just about converting, okay? So what we need to try and do is convert all of these to a similar unit of measurement. So let's do this. Let's convert gigabytes into megabytes, okay? So gigabytes into megabytes. What we're going to do, that's going to be 2,100 megabytes, isn't it? Yeah. That doesn't need to be changed because it's already in megabytes, so 300 meg. 200,000 kilobytes. Now that's smaller than a megabyte because a megabyte is 1,000,000 bytes. So that is going to be 0.2 megabytes. Is that right? Yes, it is. That's going to be 0.2 megabytes. Oh, hold on. Sorry, beg your pardon. No, it's not because it's 200,000 kilobytes. So it's going to be, take away the 1,000. I beg your pardon. Glad I double checked that. That's going to be 200 megabytes, I should have said. Yeah, because 1,000 kilobytes is a megabyte, so it's 200 megabytes. And 0.0021 terabytes. So terabytes to gigabytes, that's going to be 2.1 gigabytes, isn't it? So 2.1 gig. So what's the question say? Identify the smallest secondary storage capacity. I think it's this one, isn't it? It's going to be 200 megabytes or 200,000 kilobytes. I'm pretty sure that's correct. Doubted myself because I made a mistake. But again, putting myself in your position, or put yourself in my position, whichever way you want to do it, that might be one that you want to put a star that you come back to later. The musicians, by the way, I've just consoled in my head that is correct, so I don't need to come back to that. But if ever you're in that situation, I meant put a star, because that tells you to go over that again. The musician's recordings have an average mean file size of 3 megabytes. The musician has 1,000 recordings. Calculate an estimate of the storage space in gigabytes that the 1,000 files will require. So it's 1,000 files times 3 megabytes. So it's going to be 3,000 megabytes. Yeah, which is the same as 3 gigabytes. Calculate an estimate of the storage space in gigabytes that the 1,000 files will require. That seems too easy. It's 3 gigabytes. Maybe you get 1 mark for the method and 1 mark for the answer, but yeah, that seems too easy. I'm always suspicious when it seems too easy. A computer has a CPU. Describe what happens during the fetch, decode, execute cycle. This should be an absolute open goal for you. You've got fetching that will happen, you've got decoding that will happen, and you've got executing that will happen. I can't think they're asking for anything else here. What else could they be asking for? No. So I'm going to say data is fetched from RAM. Don't think we need to mention the program counter and all those registers at the moment. I'm going to say instructions or data is decoded. Remember, it's fetch, decode, execute cycle. So then data / instructions are executed. I sound unsure because I'm not really sure why that's a question worth 2 marks. But there's no mention of the registers there because that's the next question. So yeah, I'm going to stick with that for the time being. Complete the table by writing the name of 2 registers used in the fetch and what they do. Okay, so the program counter is 1. So let's go with the program counter. What does the program counter do? It stores the address of the next instruction in RAM. So the one that needs to be fetched next. Okay. What else have we got? We've got the ACC, the accumulator, which stores results from the ALU. 4 marks, nice and easy. State 3 characteristics of a CPU that can affect its performance. So you're talking about clock speed. What else are we talking about? Number of cores. These seem too easy to be at the end of a paper. And cache size. I don't think they'd accept cache type, cache size. So again, nice easy 3 marks. I'm suspicious when there's easy questions right at the end, because I can see that the next page says end of question paper. This was the question that all the memes were about last year then. Pictures of Harry Potter and I can't remember his red-headed friend's name, but in the front of a car screaming. Car has a follow me system that uses a cruise control feature to allow the car to follow the car in front of it. It will keep the same speed and distance without the driver's intervention. The cruise control system is an example of an embedded system. Explain the reasons why it's an example of an embedded system. Okay, well, embedded systems are part of a larger system. And in this case, the larger system could be the car. Yeah, but follow me is a small embedded system within a larger system. So I'm going to say embedded systems are smaller systems that are part of a larger system, in this example the car. Okay, they usually have one or very limited, in fact I'm not going to say limited, I'm going to say very specific roles or tasks. And what else? They will rely on sensors for data input. So 3 marks. Yeah, so the sensors are going to measure like the distance between the car, aren't they? And then speed up if they're getting too far away, or slow down if they're getting too close. So yeah, that again, quite easy. This paper doesn't seem too bad at all. State 2 items that will be stored in the ROM for the follow me system. So ROM, remember, stores things that don't need to be changed. So a great example will be the operating system, and another one will be the BIOS. Okay, there are other things that you could put there, you know, maybe like the maximum speed. So in the UK, maybe it wouldn't go above 70 miles an hour or something. I don't know, but operating system and BIOS are always the 2 safest things to put for a question about ROM. State 3 items of data that will be stored in the RAM for the follow me system. So ROM stores things that don't need to change. RAM stores current or active data. So the current distance that it'll get from the sensors from the car in front of it. It's the current distance. What else would it need to store? Maybe the current speed. And what would the third one be? So distance, current speed, required or desired distance. From car in front. So if you want to be 25 meters behind the car, that's what else it would store. I think that would get all 3 marks there. And then finally, explain why the follow me system does not need virtual memory. So virtual memory, oh, there you go. They've given us a nice, easy kind of 12 marks, and then the last 2 might challenge you a little bit. Virtual memory is where RAM is full up and it can't hold any more active data. So it has to lean on the secondary storage device to say, you know, hold my beer type thing, while it's struggling. So it needs to lean on secondary storage for a bit of help. And I'm going to guess that it doesn't need virtual memory because there's probably not a lot of data that's being used here. So not a large amount of active data needing RAM. Yeah, what I mean by that is it's unlikely to max out. That's probably not great language for an exam, but it's unlikely to use up all of the RAM. And what else? There is no mention of secondary storage. So 2 marks there. So that's not a very, very bad paper at all. I think we might have dropped 1 mark, maybe 2 marks along the way. And I know we haven't answered the essay question yet. I will do that in a follow-up video. Just to confirm, the essay question's talking about open source and proprietary licenses for software. So that's like an ethical issue. But what I do just want to share with you, because I reckon we've dropped 1 or 2 marks there, I just want to share with you what the requirement was for the grade boundaries last year. So I've got my iPad here. Let's just scroll down. Where's computer science? There we are. Okay, so for computer science paper 1 last year, you would have needed 65 marks to get a grade 9. So we dropped 1 or 2 marks in my answer there, plus the 8 marks that we didn't write for the essay question, and we still should comfortably be 70 marks or more. Sorry, we should be around the 70 marks figure. So that should be a grade 9. 61 was needed for an 8. Quite a small gap there between an 8 and a 9. That suggests that people found it relatively easy to get a grade 7 on that paper last year, but not very easy to get a grade 9 is what that suggests. And then looking down the list, 44 marks to get a grade 5. So yeah, really odd grade boundaries last year because paper 2 was definitely easier than normal. But paper 1, perhaps some people struggled with, I don't know, maybe the airport questions. So yeah, always good to know what the grade boundaries were. Please let me know in the comments if there are any questions you have about the answers that I provided, or if you're unsure or you disagree. I'm always happy to follow up and explain why. I can't share the mark scheme with you. That'll be down to your individual teachers. So if you need that, please approach your teachers at your school. And yeah, let me know what else you'd like to see in the future, or give me feedback on things that you'd like to see me change, because I do wish to do more of these videos. But yeah, please check out some of the others if you haven't already, and hopefully you're looking at this before the end of the Easter holidays. Otherwise you're leaving your revision a little bit late. Good luck this summer, everybody. Again, any questions, let me know in the comments, and I usually reply within 24 hours or so. Thanks.